Hello, my name is Martin Vityk, and today I will talk about the new Android UI development toolkit, Jetpack Compose. First of all, what is Jetpack Compose? Jetpack Compose is a new, bleeding-edge Android toolkit used to make native Android UIs. Before Compose, Android Studio used XML for all its UI views and referenced XML elements in the code. With Jetpack Compose, all UI elements are created programmatically using Kotlin APIs. How do you use Jetpack Compose? It is very simple to implement Jetpack Compose in your project. All that has to be done to use Jetpack Compose is to add an @composable tag to a function in your Kotlin code. The parameters for your composable function normally will be the data the UI needs to use. This makes Android app development a lot simpler to reason about and refactor, since UI elements and other background logic is separated. Once again, all UI work is done programmatically in Kotlin using Jetpack Compose specific language, all created in Kotlin. Now, the Jetpack Compose software engineering paradigm. Most object-oriented UI toolkits create a tree of widgets by inflating the XML layouts for each of the widget, and that then exposes their getter and setter methods and allows the app code to interact with the XML. In Compose, the widgets are not exposing their getter or setter methods, and they are not objects you update. All you have to do is just go into the UI and call it through the specific composable methods with different arguments. This creates this top-down approach for UI updates. The idea is that all data is passed down to Jetpack Compose methods as a state, and then the methods respond back to the background components of the app with an event. And this event occurs whenever the user interacts with UI, touches a specific component of the UI, or does anything on the phone. This creates a very modular relationship between the UI and the backend. Now, why would you use Jetpack Compose in the very first place? Originally, all Android UI elements are created in XML and are referenced in a connected source code file when you need to apply code to it, as I spoke about earlier. Jetpack Compose simplifies this by having all code only be contained in the source code file, removing any need for any XML. Now, stop and think. Try to think of some reasons as to why it would be more useful for an Android app development to have all code in Kotlin for UI development. Here are a couple of reasons why Jetpack Compose would make development better. First of all, there is less code. You would no longer need to use verbose XML code, which has a lot of redundancies. You also don't have to explicitly reference objects from the XML, which saves you a lot of bugs. It's also intuitive. Jetpack Compose takes care of a lot of things you would have to do manually if you programmed with XML. It will automatically update UI states as data from the app changes, instead of having to check it in your code manually. Finally, it accelerates development. Jetpack Compose is compatible with all previous Android versions, so you can implement UI elements in Jetpack Compose iteratively without having to fully convert your app to Jetpack Compose. You can also launch previews of the UI without having to fully compile the app, which makes testing new components a lot faster. We will now go into each specific topic by giving some examples for it to make a little bit more sense in Android Studio. The first point, less code. Here is an example of a regular Android activity. As you can see, this is the XML layout of that activity, and it's quite bulky. In addition to this, you would also have to reference these specific IDs if you ever want to change any text inside of the code. Now let's contrast this with the Jetpack Compose version of the same exact code. All you need is this specific composable function where you can create a column of text. In addition to this, if you ever want to change anything, you can do it inside of the composable by just setting the name you pass down into the function. So let's change easy to my own name, and you can see that it updates correctly and everything works well. Next, let's talk about intuitive. Because UI components are declared programmatically, it means that building UI is a lot more intuitive. A simple example could be seen right here. Normally, in Android, you would have to declare the UI components in the XML no matter what, which means you would have to create the text, I am name, and I am not Bob, I am name, in the Android XML file in both situations. And you would have to hide it and show it based on whatever code you had in the back end. In Jetpack Compose, everything is a lot more intuitive. Since you have the full power of the Kotlin language, you can then pass down any object or any string into the Jetpack Compose file, and it would update everything naturally. So for example, right here you see I passed down the name Martin. It says now, I am not Bob, I am Martin. Now we change the name to Bob, and it automatically updates the text inside of the Jetpack Compose file to I am Bob without doing anything else like hiding the. Finally, it accelerates app development. Jetpack Compose is significantly different from other regular Android UI development toolkits, which unfortunately makes conversion quite difficult. Luckily, Jetpack Compose does not have to be the only UI development library in your Android project. You can easily add a Jetpack Compose UI component to any part of your app, even when other parts of the app use regular Android XML components. In addition to this, you've already seen an example of one of the most powerful features of Jetpack Compose. It is the live update of UI. If you, for example, want to change anything in the UI, you can easily do that inside of Jetpack Compose, and it shows you the preview of the UI live. This is extremely useful for any UI development and makes updating and testing very, very easy. Now, this is a software engineering presentation, so I think it's very important to discuss some of the challenges in software engineering that Jetpack Compose is solving for us to understand what makes it better than previous languages. When we write code, we create modules that consist of different units. In the case of Java coding, it is classes. There are then two cases that we have to consider between units: the case of coupling and the case of cohesion in software. Coupling is the dependency among different units or classes in different modules, and it reflects the ways in which parts of one module influences another module. Cohesion is instead the relationship between units inside of a module. It shows how well grouped different units in a module are and how well they work together. When you want to write software that is maintainable and is easy to read, the goal is to maximize cohesion and minimize coupling. Jetpack Compose does this by giving the UI the ability to be cohesive. Regular Android UI development has a lot of coupling between UI elements and other back-end processes. This has to be the case because XML is not a programming language, it's a markup language, which limits the power of UI development. Since UI literally cannot be cohesive, Jetpack Compose solves this problem by giving the developer the tools of a programming language in UI development, which makes cohesion in UI quite a realistic possibility. One of the main drawbacks in Jetpack Compose is that the toolkit is still very new and is still in beta, which means that there are still bugs in the implementation and there are limited sources outside of Google documentation for help with Jetpack Compose. Luckily, any project does not have to be limited to Jetpack Compose as described earlier, so anyone can pivot from Jetpack Compose activities to regular XML activities if a certain feature doesn't work. In conclusion, Jetpack Compose is a very powerful library that improves developers' experience to create user-friendly UI. The software design practices promoted in Jetpack Compose make for modular and easy to refactor UI code. This type of programming paradigm has been seen in different mobile development platforms like Flutter and React Native. It looks like mobile development is starting to move towards this kind of top-down UI development, which I find to be very exciting.